Hello, academic stars around the world. Welcome back to Caltex Academy. In our series of complex numbers, today we're looking at division of complex numbers. In our previous video, we looked at conjugate of complex numbers, and that video has some effect directly on this video here. That is why we are able to see some conjugate kind of thing here. So if you're not familiar with conjugate of complex numbers, I strongly recommend you to go back and watch that video. The link is in the description of our video here. And without further ado, let's dive into the video. So we have some small introductory note that says when dividing complex numbers, both the numerator, remember you have to mark these two words, both the numerator and the denominator are multiplied. So we have to multiply by the conjugate of the denominator. So we already talked about conjugate, so this denominator is the key factor here, meaning what we're going to see are complex numbers that are being divided together. The process is called realization of complex numbers. What is the meaning of realization of complex numbers? Making the denominator a real number. Just like when you are looking at surds, you realize that if you're given a question of maybe 2 over the square root of 3, it's not good to leave it in this form. You can rationalize this one here by multiplying both the numerator and denominator by this denominator here. So the same thing applies in complex numbers. If you see a complex number in the denominator, like maybe 3i, we don't need to leave it in this form. We have to remove it out by multiplying the denominator and numerator with the same complex number here, or its conjugate for two numbers at the denominator, like maybe if the complex number is having all the two parts, the real and the imaginary parts. So I think this is enough introduction to our topic here. Let's take a look at a very simple example here that will lead us into another example. So I prepared for you 3 examples. Sit back, grab a cup of coffee or water, and then see me doing it for you. So part A of this question is saying we need to simplify 3 over 2i. So this is equivalent to, remember, we were told to multiply by the conjugate, but ideally conjugate comes in when we have two parts here, the real and imaginary parts. So for this one, we only have a mono number, which is 1 only. So we just simply multiply by that 1 complex part given for us at the denominator. So if this is our 2i, then our multiplication would be times that 2i here. Also the same thing happens here. So let's move on and do that multiplication. 3 times 2, we get 6. Then we attach our I into it, over 2 times 2, we get 4. And then I times I, we get I square. But we know also that I square is the same as -1. So we have to apply the same thing here. Now we have our 6. I from the numerator divided by -4, because our I will have turned into -1. So -1 times 4, we get -4. Then we can move on and divide this by 2 because we are asked to simplify. So for that case, by 2, we get -2. Then 6 by 2, we get 3. So finally, the result of realizing this is going to be 3i over 2. And I can bring the negative in front here. And that is the answer for this question. Now also let's look at part B of the question, and we have B as 3 over 3i. So the same way we can multiply this 3 by the denominator, that is 3i. Now we can have here our 3i from the denominator and also 3i here. Remember, in maths, if you're subtracting something from numerator, you have to also do the same for denominator. When you're multiplying, you have to do the same to denominator and so on. So from here, we can do this multiplication from the numerator where we have 3 times 3, we get 9, then I is attached there. So 3 times 3, we get here also 9, and we have I times I, that is I square. So again, we can have our 9I from the numerator, and then 9, let's this time replace our I by -1 directly from here, and we get 9I over -9. So -9 and this 9 here, they divide to -1. Therefore, 3 divided by 3I is the same as -1 times I is just -I. It's unusual to write -1I. This is the solution part B of question number 1. Let's move on and look at question number 2 here. So in our question 2, we're going to look at the working in the same way. This time around, we have two numbers at the denominator, and that is where our conjugate is coming in handy. So the question is 3 over 2 plus I. So what we have to do is to write our 3, and we'll multiply this one by the conjugate of the denominator, and we divide this by also the 2 plus I multiplying its conjugate, and that is 2 minus I. So we carry the same thing up here, 2 minus I. Now, opening up these brackets, we'll have here 2 times 3, we get 6. And here 3 times -I, we get -3I. So this is divided by, now here we have two choices, either to use difference of two squares, or we can just redistribute the thing using distributive law here, and we have 2 times 2, we get 4, and 2 times -1, we get -2I. Then I times 2, we get +2I, and negative times positive is negative. 1 times 1 is 1, of course. I times I is I square. So I square times 1 is just simply I square. Now the terms in the middle cancels off, and we only have our I hanging here square, but we know it is -1. So we can recopy the numerator 6 minus 3I all over 4 minus, it is this minus here, and remember, we also had that -1 as I square. So when you open up that bracket, we get a positive. Therefore, we can copy our numerator, and we divide this by the denominator, and that is 5. Since negative times negative is positive, and we have 4 plus 1 making 5. And from here, there's nothing common. We can leave it like that. If you wish, you can also separate the real parts away from the complex part by distributing our denominator to the two parts where we have 6 over 5 minus 3 over 5I. So this becomes the real part, and this is the imaginary part of the complex number 3 divided by 2 plus I. And that is the solution for question number 2. In case you have some concern, please raise it in the comment section. I'll get back to you. So with all this said, let's go to question number 3. All right, question number 3, there are two parts, A and B. So let's start with question 3A, which says we have -1 minus 2I, and this is divided by -4 plus 3I. Now this is equivalent to, so we'll have to multiply this by the conjugate of the denominator. So I can represent them by these two different brackets. Maybe our division sign there, and we have that. Also, the conjugate here should have the same color, and that is for the conjugate -4, and the sign in the middle is believed to be negative, so we have -3i. The same thing happening up here, -4 minus 3i. Then copying the numerator, -1 minus 2i, then -4 plus 3i. So after that, we can multiply these numbers one by one, starting with here, -1 times -4, we get +4. Then -1 times -3i, we get +3i. We move the next number, -2i times -4, we get +8i. And lastly, these are three things being multiplied: a sign, number, and the I. The same thing happening here. So let's go one by one. The signs, negative times negative is positive. And then 2 times 3, we get 6. Then I times I, we get I square. Now let's move to the denominator and do the same thing here. So let's multiply the denominator the same way. -4 times -4, we get +16. And -4 times -3i, we get +12i. And the other one definitely becomes also -12i. And here, positive times negative is negative. 3 times 3 is 9. And we have I square. So putting I square as -1, both the numerator and the denominator will yield us these fruits as we simplify also the terms in the middle. So from the numerator we have 4. This simplifies to 11. So we say plus 11i. And the next one here is plus 6. And replacing I square by -1. And let's go to the denominator, and we see that the terms in the middle here cancels, and we're only left with our 16. So -9, and I square is also -1. Now we can keep on simplifying in our next step here, where we have 4 plus. Okay, now let's bring this to the other friend here, and we have 6 times -1 is -6. Then we write the imaginary parts here as plus 11i. Now let's get more space and work the same from the denominator, where we had 16. Now negative and negative is positive, so we have here 9. Simplifying what we have there and the numerator, this simplifies to -2 plus 11i. So from the denominator, 16 plus 9, we get 25. Maybe making them in terms of A and B, because the question wants us to get our answer in form of A plus BI. So separating the two, we had -2 over 25 plus 11 over 25i. And that becomes our answer. So lastly, part D of the question says we're multiplying -5 minus I by -7 plus 8i, and we're dividing this by 2 minus 4i. And this is equivalent to, firstly, we need to reduce this numerator into two numbers only, real and imaginary. So let's multiply this. So negative 5 times negative 7 give us positive 35. And then negative 5 times positive 8, it gives us 40, but negative. So we say negative 40i. Now coming to the next one here, negative I times 7, we get positive 7i. And lastly, negative times positive is negative, and then I times this I is I square. 1 times 8 is 8. So we have 8I square. However, let's keep maintaining our denominator the same as we simplify the numerator to two numbers only. Now, this one remains as 35, and the term in the middle there, the 7 possible reduce this 40 to 33. So we have minus 33i. Now we can say plus 8, since I square is negative 1, so negative times negative is positive. And 1 times 8 is 8 over 2 minus 4i. Now from here, we can add this together, 35 and 8, to bring for us 43. So 43 minus 33i divided by 2 minus 4i. So the next thing we have to do is to start doing our realization by multiplying by the conjugate of the denominator. So the numerator is 43 minus 33i, and we multiply this by the conjugate of the denominator, 2 plus 4i. So we do the same to the denominator here, where we have 2 minus 4i multiplies 2 plus 4i. So let's start simplifying. Now, when we multiply 43 by 2, we get 86. These are real numbers, so 43 times 4, we get 172, also positive I. Now this one is negative 66 I, and lastly, we have the negative 33 times 4 is 132 I square, and we do the same to the denominator. Let's get more space. So at the denominator, we had 2 times 2, that is 4, and the 4i times 2, we get negative 8i. So the other one definitely becomes positive 8i. You don't have to waste time here. Whatever you get from here will be the same regardless of the sign. So if this is negative, then it must be positive. If this is positive, then it must be negative. So that's one trick we have to mark here. Then negative times positive is negative, and 4 times 4 is 16. I times I is also I square. So let's keep simplifying. We have our 86. The terms in the middle simplifies to positive because this one is bigger, and that is 106 I. Then here this becomes positive 132 because of the negative 1 from I. And we come to the denominator. We know this one also cancels out. Now from the denominator, we have 4 plus 16. Since the negative also neutralize this negative here, now we can add the two numbers together because they're real numbers. So 86 plus 132 will bring for us 218. Then plus 106i divided by the denominator, that is 20. Now we can distribute because our solution is required to be in a form of A plus BI. So moving on, and we distribute the denominator. We had 218 over 20 plus 106 over 20, and that is I as the complex part. Now if we enter this into the calculator and make it in maybe mixed fraction, we get here 10 whole number and 9 over 10. So plus the other part is 5 whole number and 3 over 10. And that is also I. So that becomes our answer for part B of question number 3. It is a little bit lengthy, and that is the purpose of this video. We start from something simple and we build it up slowly to get the idea of how complex numbers division work. So if you have gotten some value from this video, go ahead and give it a thumbs up, subscribe to the channel so that you don't miss out those upcoming videos I'm uploading. Now in our next video, we're going to look at polar form of complex numbers, where we'll learn about argument and modulus of complex numbers. See you in that video. Peace out.